BGP Part 4, BGP Route Reflectors, Confederations, and Peer Groups. Now I must say that I think I named this nugget the most effective name that I could have, because it describes exactly what we're going to talk about as we go through this. Now we just came off of BGP Part 3, which was the foundation BGP configuration, and with that knowledge you're able to get BGP up and running in just about any organization that's out there. But the foundations of BGP doesn't give you the tools that are necessary to work with BGP in a larger organization, and that's what's going to happen as we continue on through this BGP series of nuggets. In this section, in this nugget, we're going to go through the BGP route reflectors that help you get around the split horizon rule, and I'll do a little review on that once we get there. Allows your routes to hand off routes to each other when typically they would be denied, and we'll see some awesome examples of how that works. Now you can't talk about confederations without some form of Star Trek coming into the conversation, and I am going to do my best to put every possible Star Trek character in that discussion as we talk about a way that we can shape your organization as it grows and scales to a large BGP implementation. The problem is regardless of how large your system is, maybe you're a service provider with thousands of routers, you only have one autonomous system number that you're able to use. So with BGP confederations, I'll show you how we can break it down into sub-autonomous systems, and we'll get into the private autonomous system numbers, and you break it down for not only the ability to replicate routes correctly, it kind of overlaps with route reflectors, but also for manageability purposes. Finally, we'll get into BGP peer groups, and you can't look at that picture without just going, oh, two little kids sitting next to each other. And if we look at that in purely technical standpoint, these kids have some similarities. They both have hair. They're both about the same age. They're both sitting on a step, and both of them look relatively happy. But we also see some differences as well. Like this kid's laughing, this kid's just kind of smiling. This one has no shirt, this one does. This one has no shoes, well this one does. You see some differences as well. Now when we start looking at BGP peer groups, we're going to look at it in that sort of context. A lot of your BGP neighbors have similar configurations. And I'm sure as we start getting into the neighbor syntax, you're going to say, wow, I seem to be typing the same thing again and again and again for all these neighbors. Well, I'm going to show you with peer groups how you can take kind of a template configuration and apply it in a blanket statement to all of your neighbors. We'll then get into how to say, well, yeah, they're all the same except for this one aspect. This one doesn't have shoes, or maybe this one's in a different autonomous system. We're going to take a look at how to put differences in those peer groups as well. Well, let's start things off with route reflectors. Now, you may find a lot of documentation on route reflectors and see them on Cisco's website, and there's a lot of big descriptions as to what they do. They kind of flower it up and say, well, it kind of, modifies the split horizon rule and so on, and I'll tell you what, it's pretty simple. Turning on route reflector capabilities disables BGP split horizon. It can cause disasters in your network if you do it incorrectly, because it can cause loops in your network. Now to review, let me give a brief flyby. BGP split horizon is not like other routing protocols version of split horizon. What this version of split horizon says is, if I receive a route, let's say that I am router 2 and I receive it from some sort of eBGP network over here, it's going to propagate that route to its iBGP neighbor. So it's going to come in here and send it to router 1 and say, hey, here's all the routes that I've learned from Autonomous System 4300. Now router 1 is going to receive those, and this is where the rule kicks in. BGP split horizon says that if you hear about a route via iBGP, you will never send it to another iBGP peer. So when we look at router 1, it will never send that route to router 3 or router 4. Let me get those green arrows out of there so we can take a look at this on the live topology and in a live demo. I'm going to take you to router 2. And by golly, I'm just going to do a show run because I want to show you I went ahead and deployed BGP on all these routers. I did essentially what we did in the previous nuggets with the foundation BGP configuration to save us some time. I've gone in and created, this is BGP Autonomous System 6300. There's no synchronization, and that means that I don't have to hear about those routes from the internal routing protocol before I'll believe them. And I also turned off no auto summary. Now you can see that this router has a neighbor in remote AS6300, so that's an iBGP neighbor with router 1. And I also have this mystery neighbor in autonomous system 4300 that is somewhere out here in the mystery land. It'll be one of the backbone routers that we'll call it. Now that router is sending routes into us, and I also turned off auto summary because I do want those classless capabilities. Let me do a show IP BGP. This will show me the routing table, and what I see here is that I'm receiving routes 192.168.26.04, these are all /30 subnets, from that mystery backbone router. And I see the path is it's coming from autonomous system 4300 and it's internal to that system. So I'm receiving all these routes. Now let's take a look at router 1 because I want to show you the problem before we show you the solution to fix it. I'm going to go on router 1 and do a show IP BGP. And what I see here is that router 1, it's hearing about a bunch of routes. You can see there's a bunch of them coming from autonomous system 4300, and there's also some routes coming from autonomous system 2300, which is coming over here. And there's a whole duplicate set of routes that I've created from the 192.168.35 network coming internal from that one. So it's hearing about them, but look at the difference between these routing tables. I have in this routing table to the left, these routes marked as best. They are believable, and they will be passed when they see best. Now, when this router gets it, notice what's happening here. The best has disappeared, meaning it received it via iBGP, and it's not really going to be believed if I'm going to not have this turned on as a route reflector. And here's the proof. Let me hop down here to router 4. You see router 4? It only has an iBGP session with router 1. So it's going to be receiving routes from router 1, and let's see what it's received. I'll do show IP BGP. Wait a sec, did I mistype that? Wow. Absolutely nothing is what it's receiving, because that is the split horizon rule. Router 1 is receiving routes from both router 2 and router 3 coming from these autonomous systems. Router 1 is not sending any of them down here to router 4 at all. It's not receiving any routes. That's where these route reflectors can come in handy. You get to choose any router in your organization or in your autonomous system, hit it with your magic wand and say, you are a route reflector. And the BGP split horizon rules are no longer valid on this router. Now, you have to be very careful when you do this, because this rule is here for a reason. It prevents loops inside of an autonomous system between iBGP relationships. Here's the idea. Without route reflectors, you would have to have a full mesh iBGP configuration in order for the routes to propagate between all your neighbors. So all these would have to have iBGP relationships. We'd have to have these two tied together with iBGP, these two tied together. It's a full mesh. So the more routers you add, the more complex your design for BGP becomes and the more resources it consumes. Route reflector eliminates this need. However, if you do have this kind of full mesh style of relationships and you enable route reflectors, yikes, you just caused loops in your networks, because you're going to start reflecting routes that have already been heard about. You're going to have this looping mechanism every single time a loop or a route is learned and propagated inside of your autonomous system. So the best thing to do with route reflectors is to follow your physical topology and follow your iBGP relationships that are already there. You may need to remove some of the relationships. In this case, we should only have iBGP peers between the routers that are physically connected. There should be no other iBGP relationships that are unseen in this diagram. So here's the way to do it. It's actually, the configuration is a piece of cake. It's the concepts that you need to make sure you remember with route reflectors. I'm going to go to the router that I designate as my route reflector, which in this case, router 1 looks like the best bet. And I'm going to say, router 1, get into global config mode. Router BGP autonomous system 6300, and I will say, you are a route reflector. Now, we never explicitly say you are a route reflector. We will say that you are reflecting to these clients. So here's the idea. I'm going to say neighbor 10.12.1.2, which is router 2 in this case. Router 4 is 10.14. Router 3 is 10.13.1.2. So I'm going to say, for that neighbor, they are a route reflector client. Is that it? Yep. That's all there is to it. You just go in there and set each one of those as a route reflector client, and it's essentially disabling Split Horizon to that client. Thankfully, you can see these neighbor relationships resetting in the background. We don't have to do a clear IP BGP star to clear out all the sessions after we make this change. It's going to do that for us. Now, as these neighbor relationships reform, you can see they're all down right now, but they will come back up. We will see the route reflecting take place. So router 1 will receive the routes. Let me kind of, as those are coming up, come over to here to the diagram. It will receive the routes from each one of these neighbors coming in. We have routes coming from Autonomous System 2300 and 4300, and it should reflect them not only to router 4, so router 4 should have a complete table, but think about it. When they were coming in from here before, it would go up to router 1 and stop, as in router 2 never learned about those routes from Autonomous System 2300. Now it will. Now it will come through this router and reach router 2 to be able to see all those routes. So we should have a complete BGP routing table. I'm looking, all of them are up, so let's do a show IP BGP on router 1. We should see all the routes. They're all there. They look good so far. I'm going to come down here to router 4, do a show IP BGP. And sure enough, they are all being learned on router 4 as well. So iBGP Split Horizon is disabled on router 1. It's now propagating those routes through. And that's awesome because now router 4 has a complete routing table. Now, one thing you have to make sure of, I'm going to do a show IP route to make sure that they did end up indeed in the routing table, and there they are. One thing you have to make sure of, as always, is that your next hops are reachable. Remember, look up here. I have all of these routes in BGP with a next hop of 10.12.1.2 and 10.13.1.2. That's going to be these guys, 10.13 and 10.12. If router 4 doesn't know how to get to those next hops, and believe me, it has to because it has to go through router 1, it's not going to get there. That's why I have EIGRP turned on right here to allow it to learn the internal routing infrastructure. I didn't include all these 10.13, 12, and 14 networks in the iBGP updates. So I have to have some sort of mechanism, either static routes or an IGP, to learn about those internal routes. Otherwise, it will have an unreachable next hop, and these routes will never end up in the routing table. Now, you see these routes being learned from BGP, and notice their administrative distance. Brutal. It's 200. It's one of the worst administrative distances that you can have because all iBGP routes are pretty much untrustworthy according to the Cisco standard. So they set the administrative distance very high. So if there's some other way to get to those network, it most likely will be used because this is one of the highest administrative distances that you can have. The second strategy that we can use to manage the number of iBGP relationships we have inside of our autonomous system is the system of confederations. Now, a lot of people look at confederations and route reflectors as almost competing technologies, but they're not. They're really meant to be complementary technologies. Confederations are used to manage the number of resources that are consumed on your routers and really help you get a better structure inside of your autonomous system. Now, I don't have in this lab environment thousands of routers that a service router will have. So you have to kind of imagine with me as we create our system what it would look like if we were to expand each one of these routers to represent 500 routers apiece. Well, what we could do is we could divide our system into confederations. And here's the concept. Instead of these routers being a part of one big autonomous system of 6,300, we can divide them up to be a member of sub-autonomous systems. Now I'm again choosing at random mainly to demonstrate the technology where these sub-autonomous systems will be, and I'm just going to cut this one right in half. Where these sub-autonomous systems will be, but in the real world, in a service router environment, you would have a big strategy and design behind this to group similar routers and common routers together and control the number of neighbor relationships that we would have amongst each other. Now, what we could do is then go in here and say, well, these are sub. I'll put sub AS, and I'll put 65,500. And over here, I'll have sub AS 65,501. Now, 1. There we go. Now these numbers that I'm picking, these autonomous system numbers, are actually a part of a range. These are considered private autonomous system numbers. And I'm just going to jot it here at the bottom. Private AS numbers equals any number from 64,512 through 65,535. Okay. Those numbers are considered private, meaning that it's like a private address in the IP ranges. You can allocate these at will. You can go ahead and say, you know what, I just want to throw these all over my organization wherever I want to. Now, you'll never really have more than, I would even say, 10 private autonomous system numbers, but you have a range of 1,000 or so that you can use inside of your own autonomous system. The nice thing about these is that you can strip these autonomous system numbers as you advertise these out to other autonomous systems. So even though you've subdivided your BGP autonomous system into, we have 2 here, but it could be many, hundreds of sub-autonomous system numbers, as it leaves your organization into other autonomous systems, it looks as though it's coming from just the one autonomous system 6300, which is your registered internet valid autonomous system. This is a good way to help manage that internal relationship, because now router 1 and router 3, they don't have iBGP. We can go ahead and put an X through that because they think they are in separate autonomous systems. So they will use eBGP between each other, and all the eBGP rules apply. The next hop will change. It saves us some next hop configurations. There's no need for a route reflector if I'm taking router 2 routes that come from outside the system, sending them up to router 1, I don't need to reflect them down to router 3 anymore, because it sees that not as an iBGP relationship, but as an eBGP, so that it takes care of the route reflectors. Now here's a question. Think about this one. If I receive routes into router 2 from this outside autonomous system, it comes up to router 1, do I need to reflect them down to router 4? What do you think? Well, the answer is yes. This is why I say confederations and route reflectors aren't competing, but rather complementary technologies. Since this is still iBGP relationships, I will have to reflect those routes down to router 4, and vice versa. If router 4 is advertising any routes that it has up to router 1, I need to reflect them over to router 2. Now, can confederations be used in replacement of route reflectors? Yes, you could. I could put each router in its own little sub-autonomous system, but that becomes a management nightmare. This is meant to make it easier on you if you have tons of routers in an autonomous system, not harder. So again, use those technologies complementary to each other. Now, let's get into the configuration of this. There are 3 major steps to configuring BGP confederations. The first thing that you have to do, and this is horrible, is gut your entire BGP configuration that you have currently on your router. And this is why I say, if you are a service provider or thinking about being a service provider deploying BGP as your internal routing protocol, designing confederations into your setup to start with is much better. I mean, as Spock would say, it's just illogical to do it any other way. So what we have in the confederation world is we are going to have to set up router 1, router 4, and router 2 under this autonomous system. What does that mean? That means that we have to go in, I'll show you what that means. We have to go in to router 1, and I'll type in no BGP 6300, or take off the suspense there, no router BGP 6300. What that did is totally destroy all the previous BGP configuration that I had on there before. As a matter of fact, I'm going to have to go to every single one of my routers, get into global config mode, do a no BGP, or see there, I go skipping it again, no router BGP 6300 to turn off BGP routing in a standard system completely. Now, you know what? I'm going to go ahead and do that on the other routers. Oh, sorry, getting lost somewhere in my typing. I'm going to do that on all the routers, but I'm going to do that once I pause the recording, because number one, obviously, as you can see, I cannot talk and type at the same time. But also, what's going to happen is we're going to have to shut off BGP on every single one of those routers. Now, let me show you on a router that I've shut off BGP. I'm going to need to come into router 1 in this case and type in router BGP, and what autonomous system is it in? It's in a new one. 65,500. It believes it is a member of that full autonomous system. So once I'm in here, I'm going to have to configure its neighbors, and I'm going to have to configure the peers in the member autonomous system. That's going to be step one. I'm going to go on to this router and type in neighbor 10.12 and 10.14.1.2. I'll say remote AS 65,500. 10.14.1.2 is the other one. And I'm going to have to do that for each one of these peers. And that's why I'm going to pause the recording, is I'm going to have to go to router 2, router 4, router 3, and reconfigure them completely in different autonomous systems. That's step one, is to configure all the peers in their own little member confederations. From there, step two is going to be configuring the special eBGP peers between our confederations. Now, I said it treats it like a real eBGP peer, router 1 communicating to router 3 and vice versa. However, there are some special commands we have to type in to tell it, hey, even though you're communicating to an eBGP peer, it's not a real one. This is kind of the scoop behind the scenes. This is a sub-autonomous system. It's a confederation. We're going to give router 1 and router 3 the scoop on the fact that they're not really running in a real autonomous system. From there, we're going to have to configure all the confederation peers that have connections to outside eBGP systems, outside autonomous systems, to say, number one, when you're communicating with these guys, those guys aren't private autonomous systems. They are real autonomous systems, and you're going to have to do some special modifications to your advertisements to make sure that you remove these sub-autonomous system numbers, because they should not be seen. It should look as though we are all one. We are all in unity together in Autonomous System 6300. So again, those three steps: one, configure the peers in your confederation; two, configure the special eBGP peers between confederations; and then three, configure your routers that are connected to outside systems with the correct configuration. So let me go ahead. I'm going to do step one and configure all the peers within their autonomous system. I'll come back and then we'll get into step two, which is configuring the link between these guys. Okay, I've done the foundation configuration on this, so let me do a show run, and I'll do a begin router BGP. What we have here is router BGP 65,500 on router 1, and I've typed in the two neighbors, 12 and 14.1.2, which is right here, 12.1.2 and 14.1.2. So these two neighbors, we bring it back up here, are in the same autonomous system, 65,500. I haven't typed in anything other than no synchronization and no auto summary. Over here on router 3, what I did was I went ahead and set this up in its own autonomous system. I didn't do any neighbor statements either from it or to it on router 1, because I wanted you to see the whole effect there. I didn't want to cut any of that out. So I just did, again, just the base foundation configuration. I'm going to get into global configuration mode on this router, router 1. Router BGP 65500. And the first thing that I'm going to type in on each router that I come to is going to be BGP confederation, and then we have identifier. This will tell this router, number one, that it is in a confederation. It's not in a real autonomous system, but also it will tell it what the real autonomous system number is, 6300. Enter. I'm going to need to type that in on every single router in this autonomous system to let it know, hey guys, you're in this little fake autonomous system I created. The real one, whenever somebody from the outside talks to you, is 6300. Here's the cool thing. Router 5, when it peers with router 1, do you think it's going to have to peer with this sub-autonomous system number that should be private and nobody knows about? No, router 1 will peer as if it was in autonomous system 6300. It doesn't have to peer using that private autonomous system as long as we configure that identifier correctly. Now for the next one, BGP confederation peers. This command allows us to type in the AS numbers of any peer confederation autonomous system numbers that are out there. Careful on this one. We're sitting on router 1. What's the only other confederation autonomous system number? That one, 65501. So I'm going to type in confederation peers 65501 to let it know when I peer with this guy, when I type in a neighbor statement and it's going to this autonomous system, it knows that this is a private one as well. On router 3, we'll have to type that same command, except we'll say BGP confederation peers 65500 to let it know that this peer relationship goes to another private autonomous system. So that's really the the extent of the confederation commands that we'll have to type in there. There'll be a few more, but we have to type that in on every single router. And again, let me just do it one more time to solidify it in your mind. I'm going to go ahead and pause the recording as I go do all of the other routers. You can see with these configurations, it's all about going everywhere. BGP confederation identifier on router 2 now, 6300. Now on this router, do I have to type in any peer statements? No, I don't, because this one does not have any peer relationships that go to other sub-autonomous systems. It's only going to have relationships with the outside routers. So it saves us some typing. We just need to tell it its identifier on every single one of those. Let me go ahead and pause the recording. I'm going to go do this on all of them in the system, and then we'll come back and configure the eBGP relationship between router 1 and router 3. Okay, all the routers have been configured with the confederation identifier, and where necessary, and when we're looking over at router 3, I configured it with the BGP confederation peers so it can know that this sub-autonomous system is also private. Now I also, you may have seen this network suddenly appear, I also added a little loopback network to router 4 so that we can advertise this, just so we can see a network flowing around within our system before we introduce routes from the outside into this confederation. I went ahead and just called it 40.0.0.0/8, so it's a full class A subnet. And I just wanted to bring this up and show you. On router 1, I'm going to do a show IP BGP. So this is upstream from router 4. And I now have, it says it's learning that 40 network. The next hop is 10.14.1.2. Life is good, or so it seems so far. But remember, if I come on over here to router 2, which let me get back to the I put a big slash across it. Come over here to router 2. That is going to be a problem with BGP Split Horizon, because this route was learned via iBGP, and it's not going to allow it to continue using iBGP. So let me just show you on router 2, show IP BGP, nothing. Hop over to router 1. I'm going to say, router 1, you are a route reflector client for the neighbor 10.12.1.1.2. and I'll put route reflector client, and I'll hit the up arrow and do it the other way for 14. So this will allow it to advertise networks going through the system. So we're integrating route reflectors into this confederation to allow the routes to travel through. While those neighbors are coming back up, let's configure the eBGP relationship between router 1 and router 3. And the nice thing is there's not much different. I'm going to type in neighbor 10.13.1.2, which is the other side of this connection, router 3 over here, and I'm from router 1's perspective. Remote AS will be 65501. Now, because we set it up with the BGP confederation peer, and we told it that that is a private autonomous system, router 1 now knows. It goes, oh, okay, that is going to be a confederation peer. I'll establish an eBGP relationship with them. And wherever we do it one way, we have to do it the other. Router 3, our BGP 65501, and I'll type in neighbor 10.13.1.1 remote AS 65500. And just to show you router 3, the router 3 configuration, because that was kind of done off the screen, I want to make sure you get the whole scoop. It is in 65001 or 65001. My words slur together. And we have right here the confederation identifier of 6300, that's the entire autonomous system, and confederation peer 65500. So it's saying over here is a private AS, and now I see that neighbor has come up. So I can do a show IP BGP sum, just make sure, and we are exchanging routes now with that neighbor. And it looks like we received one prefix, which is, hopefully, on router 1, actually let's just do it on router 3, show IP BGP. It should be that 40 network. And you see this? Look at that. It says, I learned about the 40 network, and here's the path. It goes from 65500, and then it goes to the IGP. As in, this route was learned, it originated from an IGP, and the only time you'll see that code is when somebody has used the network statement to include it in there. We'll get more into that one in the following nugget when we start looking at aggregation and so on. However, we are now exchanging routes within this autonomous system. And let's go over to router 2 because that was where we first saw the split horizon symptom. Do a show IP BGP, and there we go. Beautiful. It's learned about it because it is now turned off split horizon. Router 1 is a route reflector for its little sub-autonomous system. Now what we need to do, we have our autonomous system running, we have to introduce the outside world. How do we communicate with outside peers when we have these sub-autonomous systems? Well, the good thing about it, and the reason confederations are so popular, is because it's all from our end. These remote systems, I have router 5, I brought in this outside system because I want to show you what it looks like from their perspective, but I also have routers connected out on the left side and out over here on the right side as well, so they don't know anything different. From their end, they're peering with a router in Autonomous System 6300. It's our end where the magic happens, and the nice thing is there's not too much magic that has to happen. We've already set up router 1 to know that, hey, you are in an autonomous system that is private. We told it it's in a confederation. It told it what its peer confederations are. It knows the story and the scoop of what's going on. So it's going to do most of the configuration for us. Router 1 just needs to know what is its outside peer. So we might as well tell it. I'm going to bring up the configuration and get router 1 into the picture. I'm going to go into router 1 and do global config mode, router BGP 65500. Neighbor, and that neighbor up there, its IP address is 10.17.1.2, 30-bit mask. Oh, and forgot the remote system. Remote AS. Oh, what? I just typed in the subnet mask. See, I do that all the time. I'm not assigning IP address. I'm telling it's the neighbor. 5300. It's a long BGP world. All right, so I now have that neighbor configured, and I'm going to hop on over to router 5 just to make sure, because it should still be configured up there. And actually, my apologies, I'm on the wrong router 5. I have multiple router 5s in this world. So I'm going to do a show IP BGP summary. It should still have the neighbor configured from before, 10.17.1.1, connected to Autonomous System 63,000. Now, as of yet, it has not gone active. We do not have that communication going through yet. So, we'll give it a sec. Hop on back to router 1. Let's do a show IP BGP summary here. And just make sure all our neighbor relationships are working. You can see that I have the 12.1.2, and there, see, patience is a virtue. 12.1.2, 13.1.2, and 14.1.2, that's all within my system. Here's all the autonomous system numbers. And now, if I do that command again, we should see that outside neighbor being active. Now, I want to show you, because in the mystery of video, I went ahead and set up already these neighbors over here. So router 3 is set up to communicate with this neighbor out here. Router 4, I just did the same command, just an outside neighbor. I want to do a show IP BGP on router 1. Watch the routes now. Look at this. Router 1 in Autonomous System 65500 is receiving these routes from, this is coming from the neighbor 10.26.1.2. Let's zone in on who that is. That's going out here into this world, Autonomous System 4300, excuse me. And we have right here 4300, all those routes coming in. And look down here, we have, look at that, it's in parentheses because it recognizes that's a confederation autonomous system. We have coming from 2300 over here, all of these routes. So we're getting all of the routes now on router 1. Now the question is it passing them to router 5 up at the top? Nope. I do that sometimes, just jump randomly between screens. Let's get up to router 5. I'm going to do a show IP BGP and see if those routes are coming through. Wow, and they are. I'm sitting on router 5 up here. Notice anything missing? I do. I see these private autonomous system numbers, which are not valid, but thanks to the confederation configuration, it's automatically stripped off as soon as we communicate with an outside peer. You see all these routes, they're all coming from within that autonomous system, but all of those private autonomous system numbers are removed when it communicates with a true external peer. Now, it didn't always do this, and there may be times where you have to manually configure that stripping of the private autonomous system. I just want to make sure you know the command to type in when you need to. I'm going to type in router BGP 6550. on router 1, and I'm going to type in neighbor. Now let's say that we either had an iOS that didn't automatically strip it, or we're communicating, and maybe this is a private autonomous system altogether. We're not using confederations. I've had that situation when you're working with an internet service provider. They have their autonomous system. You don't want to buy one, so they give you a private AS number that they will strip for you when you send it out. Or you can do it. I'll do neighbor 10.17.1.2, and here's the command. It's pretty logical. Remove private autonomous system. Enter. So if it didn't do it automatically for us, typing in this command would ensure that all autonomous systems that are considered from that private range, 64.5.12 through 65.5.35, this range right here, it will be removed as soon as it starts communicating outside of that autonomous system. So that, I think it's quite a config. I just want to take a moment and just stare at that topology. It works. It's all communicating together. Between our confederations we're communicating, between outside systems we're communicating, and the outside systems know no difference whatsoever between the autonomous system being a real autonomous system or private autonomous systems inside. The final topic that I want to talk with you about isn't directly related to route reflectors or confederations, but can help you out in the configuration. The reason I bring it up right now is because at this point, our BGP neighbor statements are starting to get a little bit longer. As in, if we were to jump on a router, and let me jump on one right now and do a show run and begin with router BGP so I can focus right in on it, we see that, you know, we have quite a few neighbor statements. And this is minor compared to when you get to a service provider. You'll have neighbor statements that just go on forever with all these different options. And these are just a couple of the options that we can apply. I mean, you can add in authentication, eBGP multi-hop. There's all kinds of other things that you can apply to each neighbor. But notice, a lot of these things are beginning to be a little redundant. I want to go back to that analogy that I gave at the beginning of this nugget when we talked about these kids. I mean, would it be easier to say that, you know, Johnny has hair, Johnny has a nose, Johnny has arms, Johnny has legs and feet, and then Sam has hair, Sam has a... No, you don't want to do that. You just want to say these kids have hair, these kids have noses, these kids have arms. You kind of group them together. Now, the funny thing was, I digress a little bit, these pictures, I kind of get at random from clip art and so on. And it was funny because my wife walked in as I was putting these slides together, and she goes, "That kind of looks like you." And I looked at it, I go, you know, that kind of does. When I was a kid, as a matter of fact, I grabbed a picture of myself. Check this out. I'm going to move it right next to this kid. This is me as a small lad. My goodness, I have like a twin out there somewhere. What better way to talk about peer groups than this? We are nearly identical, so you don't want to describe each and every attribute on each one of us. You just say those kids are identical, except this guy, you know, is sitting in front of a stump with a little older clothes, flannel shirts on and whatnot. That's the same thing with peer groups. Here, watch this configuration. I'm going to get into router BGP 65500, and I'm going to type in neighbor. But instead of typing in an IP address, I'm going to type in a tag or a name for this peer group or this neighbor. I'm going to type in internal, because these are going to be for the internal peers that are grouped together in my little sub-autonomous system here. And I'm going to type in peer group just to let it know I'm creating a peer group. That's the only unique command that's there for a peer group. Now I'm going to type in neighbor internal and configure it just like I would a real neighbor. I'll say remote AS 65500. And I'll type in neighbor internal route reflector client, because I have my internal clients that are route reflectors. And what I'm doing is I'm looking up here at my neighbor configuration. I'm going, okay, well, I've got these two neighbors, 12 and 14, that have nearly identical options. And typically we would have plenty more options before we start doing this, but I want to give it to you early so you can see it to start off with. And now what I can do is type in neighbor. Instead of defining all those individual options for each one of them, I'll say 10. Let me get those IP addresses, 10.12.1.2, and I'll say peer group internal. And I'll say neighbor 10.14.1.2, peer group internal. Now let me go back to the running configuration, and I'll begin with the router BGP. You can see that those separate entries for each one of them have been replaced by a grouping. We have now this neighbor internal that has all of the options, and we could keep plugging options in there. And I've just said, you know what, for this neighbor, get all of its configuration from that peer group called internal, so it gets all of its options. Now, looking at these pictures, you notice it reset those neighbor relationships when I did that. But when you're looking at these pictures, there are a lot of similarities, a scary amount of them. But there are some differences as well, as in, I could say, well, that guy has a short sleeve shirt and I have a long sleeve shirt. So in the same sense here, let's say there were some options that were unique. Well, if I were to come in here and go into router BGP 65500 and type in neighbor 10.14.1.2, and maybe he had a unique option, like maybe a unique authentication or a unique eBGP multi-hop. I could say for that neighbor, he's going to break the mold a little bit and maybe eBGP multi-hop 2. And at that point, it will add those individual characteristics to that neighbor. So I won't say it overrides, but it does, in a sense, beat out the peer group because it's more specific to that neighbor. So it will store each one of those. This peer group is a nice way of grouping all the common things together. And by the way, I think one of the most important things I haven't even said, it does save your router plenty of processor cycles when it's trying to connect to all and manage all the individual neighbor sessions. If it can group them together using a template, it's much easier on the processor and memory usage than it would be if we typed in all these individual characteristics for each and every neighbor. We have expanded our BGP understanding in this nugget by adding to the arsenal of tools that we have route reflectors, which essentially disables BGP split horizon. We also added confederations, which allows us to create sub-autonomous system numbers and route between them. And yes, I did try to keep my Star Trek jokes to a minimum. I think I only had one. From there, we got into the BGP peer groups, and I learned something new, that I have a twin out there somewhere, that allows you to group together common configurations for the neighbor statements under one peer group entry, and then apply it to the individual IP addresses of your neighbors. I hope this has been informative for you, and I'd like to thank you for viewing.